Okay, today we have a position that is really very, very simple. It's simple math, and basically, backgammon is all math. Everything is math, except for uh, situations where you're going to play a little poker and try to read your opponent and maybe intimidate him by doubling or intimidate him by comments or whatever. There's the social aspects of the game, but the game truly is a mathematical game. Jason Lee and I are going to be making a presentation to the Math Museum of America on behalf of Backgammon to show them why backgammon should be a permanent exhibit in the museum, and why backgammon is all math, and why backgammon should be taught in the schools to help children learn math skills. I certainly started my kids on backgammon very, very early, and I'm proud to say they're both very, very strong at math, and it helped a lot of other skills. I think backgammon is a great game for kids. It teaches them how to deal with uncertainty, with luck, with how to accept bad luck as well as good luck, and how to win and lose gracefully. But largely, you learn a lot of math. Well, this is all math. Red's on roll. Should red double? If red doubles, should white take or drop? Well, I always approach every cube decision with Woolsey's law. If I'm red here, I never decide whether to double until I decide whether or not white takes or not. And using Woolsey's law, if I conclude that white does not have a take, then I'm going to certainly double. And if I'm not quite sure if he has a take or not, I'm still going to double. And if I'm sure he has a take, I'm then going to double if I have enough market losers. And in situations like this, you just have to count them. So the first question is, does white have a take? Well, white is down 21 pips in the race. He's very unlikely to win this race. It's almost certain that the best chance that white has to win, and maybe, now I wouldn't say the only chance, he could roll double six or double five and catch up in this race, but pretty much the only chance he has to win is to hit red and get a shot at red. Well, how often will red leave a shot? How often will white get a chance to hit him? Well, you count. First, basic backgammon math skills. The difference in the two positions is 8 between this pip and this pip. How many times will red, if red rolls an 8 and hits white, red's going to win every time unless white rolls a 6-1 immediately. If red rolls a 9 or higher, you can pretty well kiss this game goodbye if you're white. So it's really not brain surgery to figure out the odds of either of those two things happening. Well, we know how many 8s there are. There are 6 ways to roll an 8. We know how many ways to roll a 9 or higher. But if you don't know all those numbers off the top of your head, what I always recommend people do is they go through I think you should go through the alphabet, which means you go through every roll. And it's not that hard to do, and once you get in the habit of it, you can do it very quickly. So I always start with one end or the other. So let's start with the high end. Let's start with the good rolls for red. And we start with all the 6s. What rolls get by or hit? 6-6, 6-5, 6-4, 6-3, 6-2. 6-1 doesn't get by. So all the 6s, there's 11 6s, except for 6-1, and there's a 6-1 or a 1-6. That counts as 2 rolls. That means there's 9 rolls where if that has a 6 in them where red is a success. I'm going to just, for the sake of right now, assume that the 6-2 and the hits win automatically. I'm not going to take into account the 6-1 that red could roll back and the white could roll back and hit. But let's just take those for now. That's 9 6s. Then I go with the 5s. I start with 5-5. I don't do 5-6 because I've already counted 5-6 and 6-5 with the 6s. So I have 5-5, 5-4, and 5-3 that either hit or get by. That's 5 rolls. 9 and 5 is 14. By the way, I'm doing this in my head, and this is how you do it over the board too. You're not allowed to use pencil and paper. Now I've done the 6s and 5s, and I have 14. Now I do the 4s. Double 4. That's the only roll that will get by. So now I'm up to 50. Now I do the 3s. Double 3. Double 3 gets by. Now I'm up to 16. But now I do the 2s. Double 2s hits. Now I'm up to 17. Now 1836 is half. So not quite half the rolls. Red is pretty much of a winner. Again, if he hits them, white could roll a 6-1. If red gets by, white could roll double 6 or double 5 and still have a good chance, but not necessarily That doesn't cost red the game. So about half the time right there. So looks like white's got 50% chance of getting a shot. Now sometimes he doesn't get a direct shot. What happens if red rolls a 2-1, 3-1, 4-1, 4-3, 4-2? There's a lot of times where white only has an 8 shot. How many ways are there to roll an 8? I know from automatically it's 6 ways. But if you're not sure, count the ways you can roll an 8. You can roll a 6-2 and a 2-6. You can roll a 5-3 and a 3-5. You can roll a double 4 and you can roll a double 2. That's 8 ways, that's 6 ways to roll a 6. So if all those other times, you have 17 times that red gets by, and the times that he doesn't get by, white only has, on a lot of those times, and we could count exactly how many, 636 chance of hitting. That's about 17%. And then the times that red is forced to leave a direct shot, where he rolls a 6-1, 5-2, 5-3 hits. So 5-1 would force him. All the 5s that don't hit or get by. All the 6s that don't either get by, which is 6-1. And the rest can all be played inside for red. So that's not very many times, and white's only going to hit him about maybe 35% of the time. He's going to have a 3-shot or a 2-shot or a 1-shot. So this looks like, and if we did it in more detail, I could give you almost an exact number, but this looks like a drop. Therefore, if I'm red, I double, and if I'm white, I pass. It's all numbers, it's all math, and over the board, you do it fairly quickly by estimating and rounding off like I just did. If you gave it as a test, we could come up with almost exactly the odds of white winning here. Let's see if I'm correct that this is a pass. Pretty big pass. White wins. Actually, it's not that far away from a take. A take is around 21.5% or so in a money game or unlimited game, or in a normal match score, which would be 11 away, 11 away, or 7 away, 7 away even would apply here. So it's not that far away, but it's enough to be a blunder to take the cube. Now, what if white was closer? This would be even better for red. There's more numbers now that hit or get by. This would be a big drop. Pretty easy to see that. 26% error to take. He's only got 16% winning chances. What if white were further? I think this has to be a take now. Now, if you count the number of rolls that get by, it's very few. He's got to roll 10, 11, or 12 to get by. And if he hits with a 9, white will have a direct return shot. He's going to hit back 30% of the time. And there's a lot more ways that white can win this game. So now I'm sure it's a take. Is it a double? Well, that's when you go to market losers. Certainly you've lost your market if you roll a 10, 11, or 12. Well, there's only one way to roll a 12. I'm sorry, there's more than one. There's 3 ways to roll a 12. I got to remember my own rules. Why are there 3 ways to roll a 12? You can roll it with a 6-6. Yeah, how about a double 4? How about a double 3? Aren't those 12s? So there's 3 ways to roll a 12. How many ways are there to roll 11? There's 2 ways, 6, 5, and 5, 6. So now we have 3 plus 2 is 5. Plus how many ways are there to roll a 10? Double 5. And what else? 6, 4, and 4, 6. 3 more ways. So there's very few ways to get by. How many 9s are there? Well, there's 6, 3, and 3, 6, and 5, 4, and 4, 5. I'm not going to count double 3 because double 3 hits and gets by. So there are 4 times where you're going to get a direct shot back. So that is, and there are many, many times where he only gets an indirect shot where you might come a little bit closer. So this position becomes a lot less clear. It isn't obviously a double. It's obviously a take. But if you actually count, do you think you're going to lose your market 25% of the time? The answer is yes, way over 25% of the time. Why is it way over 25% of the time? Because the bad rolls, the ones where you leave shots, are only bad if you get hit. And you're only going to get hit about 25% of the time. So this gets closer to being a winning position for red and many, many rolls, and it would probably be a pretty sizable double, because all of the bad rolls are only bad if you get hit, and that's really going to be something in the range of 30 to 35% of the time. Pretty much has to be still a double, but a big take. Let's see. Okay, double, big take. And again, over the board, we could actually calculate these numbers. Why do we have to calculate these numbers when we know it's a big take? Well, it was easier here because the take point, this is a normal match score of money game. What if the score was 3-away, 3-away? Is it still a take? The score of 3-away, 3-away, when you start getting into scores, you have to take into account the take point. And the take points vary. Well, at 3-away, 3-away, your live cube take point averages out to around 25%. This would be a very small take at 3-away, 3-away, and of course, a big double. Let's test it. You go to match play, change the score to 0-0 to 3 or 3-away, 3-away. Should be a small take. Pass. I would have gotten it wrong. Not too wrong. 0.013. Oh, 0.001. I don't mind making that kind of a mistake. I said that the average take point is around 25%. It drifts. It drifts depending on your recube vig, your chance of catching up, and all kinds of other things about the position, because it's actually basically your chance and your value of recubing. And white doesn't have a really, really strong recube here. There's only one way in the world after white takes this cube that he's going to have a recube, and that's if he hits. Well, again, I'm wrong. He could roll double sixes and get a recube that way, but most of the time, if he gets in a recube, it's because he's hit, and that recube doesn't have a lot of value, because if he's hit, the game is pretty much over. The cube didn't gain him a lot of extra equity. So that's why that 25% number is probably not the right number here. In fact, we've proven that it's not the right number here. The right number here is probably 26.58 because here we are within 1% of a take. Okay, have I made my point? Is backgammon math? Is this game a game of logic and math? Is this a great way to teach yourself and children math? Is this too much math for you? Do you love to play backgammon because it's fun and you don't want to do all this work? Then be my guest. Keep playing it because it's fun, but don't expect to become really, really good at it. Just have fun. Make sure you don't have to play Neil Kazaros like I did last night and have to face somebody who is using math all the time. Neil killed me, by the way. And not surprisingly, he usually kills me. I get lucky once in a while, but the better player is going to win largely because of these math skills and this ability to figure these things out over the board. I hope this was instructive for you. Hope it was fun to see me make a couple of errors along the way, and we will see you again soon. Bye-bye.